Hello, in this lecture we'll find out the area of the shaded region. In the drawing we have two semicircles that intersect with each other at those 2 points. You know that those two semicircles can point to each other, that is to say they are identical, therefore they are also the same areas. You know that this is angle ABC, that equals to 15 degrees inside. The diameter AB of one semicircle equals to 5 units in itself, and therefore the diameter of this semicircle CB must be also equal to 5. If the diameter AB is equal to 5, it means that the radius must be equal to half of it. That is to say, it is 5 over 2. So we define the center of this semicircle, this point is point O. So the radius OB of this semicircle is equal to 5 over 2, or 2.5 units. Likewise, the radius OA of this semicircle is equal to 5 over 2, or 2.5 units in its length. In the next step, we define the intersection point between the diameter CB of this semicircle and this other semicircle. This point is point M. So, in the next step, we will do a construction, that is to say, from point M, we will draw perpendicular on AB. Again, from point M, we will draw perpendicular on the diameter AB of this semicircle. So actually, this angle equals to 90 degrees inside, and this angle also equals to 90 degrees inside according to our construction. We define the touching point of the perpendicular from point A and the diameter AB. This point is point P. In the next step, we will join points A and M together by a straight line. By joining points A and M, we create peripheral angle AMB. This is peripheral angle AB that subtends on chord AB, that is the diameter of this semicircle, and therefore it must be equal to 90 degrees inside according to rule 7. So I pitch quickly on rule 7. According to rule 7, if a peripheral angle subtends on the diameter of the circle, then it is equal to 90 degrees in each side. So in the drawing we have a circle. This is peripheral angle ACB that subtends on chord AB, that is the diameter of this semicircle. And therefore, peripheral angle ACB must be equal to 90 degrees in its sides because it subtends on the diameter of this circle. So any peripheral angle that subtends on the diameter of the circle must be equal to 90 degrees in its sides. This is first rule about semicircles. Semicircles, so doesn't matter. It's a semicircle or circle, it is the same rule. So we have in this semicircle AB, we have peripheral angle ACB that subtends on chord AB, that is the diameter of this semicircle, and therefore it must be equal to 90 degrees in size according to rule 7. In the next step, we calculate the area of this right triangle A and B by using two different methods. The area of triangle A and B is equals to the base AB times the height PM over 2. That is the first way. So we define the height MP, the perpendicular MP is H. So MP equals to H units in itself according to our definition. So the first method to calculate the area of this triangle A and B will be the base AB times the height PM, that is edge over 2. The second way to calculate the same area of this height triangle A and B will be the base AM times the height to the base MB over 2. So the area of triangle A and B according to the first method must be equal to the area of triangle A and B according to the second method. So according to the first method, the area of this triangle A and B is equal to the base AB times the height edge over 2. And again, the area of this triangle A and B, the right triangle A and B according to the first method is equal to the base AB times the height edge over 2. AB is 5, according to what is given in the question, times the height edge is unknown, so leave it as it is. So the area of this triangle A and B, according to the first method, is equal to 5 edge over 2, square root it inside, and it must be equal to the area of triangle, the right triangle A and B, the same right triangle A and B, according to the calculation according to the second method. According to the second method, the area of this triangle A and B will be equal to the base AM times the height MB over 2. And again, according to the second method, the area of triangle A and B is equal to the base AM times the height to the base MB over 2. So the area of triangle A and B according to the first method must be equal to the area of triangle A and B according to the second method. So in total, from this equation, we will derive that 5 edge over 2 equals to AM times MB over 2. Those two sides are equal to each other. So according to equation 1, I should found out that the area of triangle A and B according to the first calculation, it is equal to 5 edge over 2. And it must be equal to the area of the center triangle A and B according to the second calculation, to the second method of calculation, that is the height AM times the base MB over 2. So here we have 2 on both sides of this equation, so we multiply this equation by 2, and find that according to equation 1, we should find out that 5 times H equals to AM times MB. What is the values of AM and MB? This is side AM and this is side MB. The question is, what is the values of those two sides AM and MB? So I copy the right triangle A and B in a new page, and we analyze this right triangle in order to find out the value of AM and MB. So actually, this is triangle A and B, that they come from the right triangle A and B, that they come from the original domain. In this triangle A and B, sinus 15 degrees equals to AM over AB. So here we multiply this equation by AB and get that AM equals to AB times sinus 15 degrees. AB is 5 according to what is given in the equation, so we'll substitute AB by 5 and get that AM, the missing side AM, equals to 5 times sinus 15 degrees. So we found out the missing side AM. We also know that in this right line AMB, cosine 15 degrees equals to MB over AB. MB is the missing side, so we leave it as it is. Over AB, AB is 5. So total according to equation 2, we found out that cosine 15 degrees equals to MB over 5. And again, according to equation 2, found out that cosine 15 degrees equals to MB over 5. Here we multiply the equation 2 by 5, and find that according to equation 2, MB equals to 5 times cosine 15 degrees. This is according to equation 2, and according to equation 1, we already found out that AM equals to 5 times sinus 15 degrees. So for we found out that side MB equals to 5 times cosine 15 degrees in its side, and side AM equals to 5 times sinus 15 degrees in its side. So, return back to our equation that says that AM equals to equation 1, according to equation 1, 5H equals to AM times MB. According to equation 1, 5H equals to AM times MB. So 5H equals to AM. AM is 5 times sinus 15 degrees times MB. MB is 5 times cosine 15 degrees. So in total, according to equation 1, we actually found out that 5H equals to 5 times sinus 15 degrees times 5 times cosine 15 degrees. So here we divide the equation 1 by 5. So you get it according to equation 1, 5H over 5 is H equals to, here we have 5 we get cancelled, and you left only with 1 5. H equals to 5 times sinus 15 degrees times cosine 15 degrees. Because again, according to equation 1, we should find out that H equals to 5 times sinus 15 degrees times cosine 15 degrees. We have the algebraic identity that says that 2 times sinus A times cosine A equals to sinus 2A. And again, we have the algebraic identity that says that 2 times sinus A cosine A equals to sinus 2A. So here we divide this equation by 2, and finally get that according to this equation, sinus 2A over 2 equals to sinus A times cosine A. So according to this algebraic identity, and according to this trigonometric identity, sinus 2A over 2 equals to sinus A times cosine A, we get here that H equals to 5 times sinus 15 times cosine 15, according to this trigonometric identity, will be equal to sinus 2 times 15, that is 30 degrees, over 2. And again, according to this algebraic identity, sinus 2A over 2 equals to sinus A times cosine A. We get that sinus 15 degrees times cosine 15 degrees equals to sinus 30 degrees over 2. So total according to equation 1, we found out that H equals to 5 times sinus 30 degrees over 2. And again, according to equation 1, we found out that H equals to 5 times sinus 30 degrees over 2. Sinus 30 degrees is 1/2, so sinus 30 degrees in this equation by 1/2. And get finally that H equals to 5 over 2 times sinus 30 degrees is 1/2. So total we found out that according to equation 1, H equals to 5 over 2 times 2, that is 4. So total H equals to 5 quarters. This is line thread MP that equals to H, and H equals to 5 quarters. Our task is to find out the area of this shaded region. So we define this area is actually sector. It is not a sector, but it is area of this shape A and B. Define the area of this shape A and B as A, that is to say it is equals to A square units in its size according to our definition. Likewise, we define the area of this shape that is actually a semicircle. We define the size of this region as B, that is to say it is equals to B square units in its size according to our definition. And finally, we define the shaded area, that is the area that we are looking for in this question, as C. That is to say it is equals to C square units in its size according to our definition. So what is the area of this semicircle AB? The area of this semicircle AB from the drawing, it is very easy to see that the area of this semicircle AB, first of all, before that, because of the fact that those two semicircles can go into each other, they have also the same areas. That is to say, the area of this semicircle AB is equal to the area of this semicircle CB. Because they can go into each other, they must also the same areas. But what? So this is equation 1. So the area of semicircle AB equals to the area of semicircle CB, because they can go into each other. That is to say, they are identical, therefore they have also the same areas. But what is the area of this semicircle AB? From the drawing, it is very easy to see that the area of the semicircle AB equals to A plus B. And the area of this semicircle AB is equals to the area of this semicircle CB, because they are identical. So what is the area of this semicircle CB? From the drawing, it is very easy to see that the area of this semicircle CB in total equals to B plus C. So the area of semicircle AB equals to the area of semicircle CB because they are identical. That is to say, A plus B equals to B plus C. Here we subtract B from this equation. B is the size of this. It is not a semicircle, but it is very similar to a semicircle. The size of this shape. So A plus B equals to B plus C. So here we subtract B, that is the size of area, from this equation 1, and get that according to this equation 1, A equals to C. That is to say, the area of this shape is equals to A squared inside equals to the shaded area C. That is the area that we are looking for in this question. Because of the fact that those two areas are equal to each other, you can find out the area of this shape, then defined as A squared inside, and this will be equal to the area of this shaded region, that is the area that we are looking for in this question. So we have to just find out the area of this shape, and define as A squared inside. In order to do it, we just join points O and C together by a straight line. By joining points O and C, you can do sector AOC. This is sector AOC. The length of those two circles, so the radius of the circle, that is 2.5. So what is a sector? A sector is a portion of a circle enclosed by two radii and the arc between them. It is like a slice of pizza. This is a sector. The green shape is a sector. The green shape is a portion of this circle. The two AO and OB, they are the radii of this circle, is equals to R. The two radii are defined as the length of this sector. Angle between the legs of this sector is theta. So a sector is a portion of this circle enclosed by two radii and RKB between them. What is there of this? Again, a sector, it is like a slice of a pizza. What is the area of this sector AOB? First of all, the rounded line above AOB is the sign for a sector. It means sector AOB. So the area of this sector AOB equals to pi r squared. That is the area of the circle that contains the sector times the angle between the legs of the sector, that is theta, over 360 degrees. Repeat again. The area of this sector AOB equals to pi r squared. That is the area of the circle that contains the sector times the angle between the legs of the sector, that is theta, over 360 degrees. So the area of the sector AOB equals to pi r squared times theta over 360 degrees. So according to this formula, you can find out the area of this sector AMC. But before that, what is the angle between the legs of the sector, between MO and MA? What is the size of this angle? In order to find out the size of this center angle MOA, we will implement rule 13 in our drawing. In our drawing, those two angles, they are both subtended on the same chord called AM. Again, this is center angle MOA that's subtended on chord AM. Likewise, this is peripheral angle MBA. It is also subtended on the same chord called MA. According to rule 13, the size of the center angle is twice as large as the size of the peripheral angle that's subtended on the same chord called MA. So repeat quickly on rule 13. According to rule 13, the center angle is twice as large as the peripheral angle subtended on the same chord. We have a circle. This is peripheral angle ACB that's subtended on chord AB, and it is equal to theta degrees inside. Likewise, this is center angle AOB that's subtended on the same chord called AB. And because of the fact that those two angles are both subtended on the same chord called AB, the center angle must be twice as large is this triangle that's subset on the same chord called AB. Because of the fact that the size of this triangle ACB is equal to theta, the size of this triangle AOB that's subset on the same chord called AB must be equal to 2 theta. Okay, so we can implement all 13 in our drawing. Right? In our drawing, this is triangle MBA that's subset on chord AM or MA. Likewise, this is triangle MOA that's subset on the same chord called AM. And because of the fact that those triangles subset on the same chord called AM, the triangle must be twice as large as this triangle that's subset on the same chord called AM. Triangle ABC equals to 15 degrees, and therefore triangle MOA must be equal to 2 times 15, that is 30 degrees, according to rule 13. So the size of triangle AOM is 30 degrees. So, what is, we have to find out the size of this shape. That is, we know that it is equal to h coordinate in size according to our definition. Actually, this shape MB8 includes also the arc. It consists of two shapes. The first shape is sector MOA, and the second shape is this triangle MOB. And therefore, there of this A will be equal to the area of the first shape, that is actually the area of this sector AOM, plus the area of this triangle MOB. So write it down. The shaded area is equal to C, and C equals to A. So we have to find out, so the shaded area is actually the area of this shape, because C equals to A. So the area of this shape, so we can write down that the shaded area is equal to the area of this sector MOA plus the area of this triangle MOB. And again, the area of this shape that is actually A, and A equals to C, and therefore it is actually the area of the shaded region. In total, it will be equal to the area of this sector MOA plus the area of this triangle MOB. And again, the size of the shaded region, in total, it is equal to the area of sector AOM plus the area of triangle MOB. What is the area of this sector MOA? The area of this sector MOA is equal to pi r square. That is the area of the circle that contains the sector times the angle between the legs of the sector, that is 30 degrees or 360 degrees. And again, the area of this sector MOA equals to pi r square. That is the area of the circle that contains the sector times the angle between the legs of the sector, that is 30 degrees or 360 degrees. And we have to add also the area of the triangle MOB. What is the area of this triangle MOB? We choose the base as OB. OB is the radius of this semicircle is equal to 2.5, so choose the base as OB times the I to the base. The I to the base must create 90 degrees with the base. Is MP creates 90 degrees with the base. OB. So it is times the height edge over 2. So in total, the area of triangle MOB equals to the base OB times the height edge over 2. R is 5 over 2, therefore R squared is 5 over 2 squared. So pi r squared is pi times 5 over 2 squared. And we have 30 degrees over 360 degrees is 1 over 12. Plus OB times edge over 2. OB is the radius of this semicircle, is equals to 5 r ups. Times the height edge. Edge is 5 quarters. Divided by 2. So here we have 5 over 2 squared equals to 5 squared, that is 25, over 2 squared, that is 4. So it is 25 pi over 4 times 12 plus we have 5 times 5 is 25 over 2 times 4 is 8 and 8 times 2 is 16. So in total in order we have 16. So in total we found out that the size of this shaded area is equal to 25 pi over 4 times 12. 4 times 12 is 48. So it is 25 pi over 48 plus 25 over 16. 25 pi over 48 plus 25 over 16. In total it equals to 3.2 square units in its size. So in total we should found out that the area that we are looking for in this question, that is the area of this shaded region, is equals to 3.2 square units in its size. So in the next step, I'll summarize the lecture. In this lecture, our task is to find out the size of this shaded region. So in the drawing, we have two semicircles that intersect with each other at those 2 points. We know that the diameter AB is equal to 5 units in its length, and those two semicircles are identical. Therefore, they have also the same areas. Again, our task is to find out the size of this shaded region. So first of all, we define the center of this semicircle. This point is point O. We define the intersection point between CB and this semicircle. This point is point M. We define the center of this circle. This point is point O. From point M, we do perpendicular on AB. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the turning point of the perpendicular from point M and AB. This point is point P. And in the next step, we join points A and M together by a straight line. We join points M and O together by a straight line. So this is peripheral angle AMB that subtend on AB, that is the diameter of this semicircle, and therefore it must be equal to 90 degrees in its size according to rule 7. According to rule 7, any peripheral angle that subtend on the diameter of the circle must be equal to 90 degrees in its size. Therefore, peripheral angle AB that subtend on AB, that is the diameter of the circle, must be equal to 90 degrees in its size. In the next step, we calculated the area of this right triangle, triangle A and B, by using two different methods. According to the first method, this right triangle A and B equals to the base AB times the height edge over 2. According to the first method, the right triangle A and B equals to the base AB times the height edge over 2. AB is 5, so it is 5 edge over 2. According to the second method, they have this height triangle A and B equals to the base AM times the height to the base MB over 2. Height triangle A and B equals to the base AM times the height MB over 2. We have 2 on both sides of this equation, so 2 will get cancelled. In total, according to equation 1, we found out that 5H equals to AM times MB. In the next step, I copied this right triangle A and B in a new page and we analyze this right triangle. This is the right triangle A and B that I copied from the original domain. This right triangle A and B, sinus 15 degrees equals to AM over AB. Okay. Sinus 15 degrees equals to AM over AB. AB is the hypotenuse. So here we multiply this equation by AB and found out that AM equals to AB times sinus 15 degrees. AB is 5, so substitute AB by 5 and found out that AM equals to 5 times sinus 15 degrees. Likewise in this right triangle A and B, cosine 15 degrees equals to MB over AB. Cosine 15 degrees equals to MB over AB. So it is MB over AB. AB is 5, so substitute AB by 5. So in total, according to equation 2, cosine 15 degrees equals to MB over 5. Again, according to equation 2, cosine 15 degrees equals to MB over 5. Here we multiply this equation 2 by 5 and found out that MB equals to 5 times cosine 15 degrees. This is according to equation 2, and according to equation 1, we have only found out that AM equals to 5 times sinus 15 degrees. So if we found out that those two, this inside AM and MB of this right triangle MB. AM equals to 5 times sinus 15 degrees and MB equals to 5 times cosine 15 degrees. Okay, so it is a number that we can calculate the value of cosine and then get a number. Okay. So according to equation 1, 5H equals to AM times MB. So we can substitute AM by 5 times sinus 15 degrees and substitute MB by 5 times cosine 15 degrees. And in total we get that 5H equals to MB, that is 5 times sinus 15 degrees, times AM, that is 5 times sinus 15 degrees, times MB, that is 5 times cosine 15 degrees. So in total we found out that H equals to 5 times sinus 15 degrees times cosine 15 degrees. After we divided this equation by 5, we found out that H equals to 5 times sinus 15 degrees times cosine 15 degrees. We have the trigonometric identity that says that 2 sine A cosine A equals to sine 2A. Again, sine 2A equals to 2 sine A cosine A. Here we divided this trigonometric identity by 2 and found out that sinus 2A over 2 equals to sinus A times cosine A. Sinus 2A over 2 equals to sine A times cosine A. According to this algebraic identity, according to this trigonometric identity, we get that H equals to 5 times sinus 15 degrees times cosine 15 degrees. According to this algebraic identity, will be equal to sine 2A over 2. So it is equals to sine 2 times 15 degrees over 2. 2 times 15 degrees is 30, so total will be equal to sinus 30 degrees over 2, according to this algebraic trigonometric identity. So in total, we found out that H equals to 5 times sinus 30 degrees over 2. And again, found out that H equals to 5 times sinus 30 degrees over 2. Sinus 30 degrees is 1/2. So substitute sinus 30 degrees, substitute sinus 30 degrees by 1/2, and I found out that H equals to 5 over 2 times sine 30 degrees is 1 half. So in the numerator we have edge equals to 5 times 1, that is 5, over 2 times 2 is 4. So in total we should find out that edge equals to 5 quarters in its length. This is line segment MP that equals to edge, and edge equals to 5 quarters in its length. Our task is to find out the size of this shaded area. Because of the fact that A equals to C, we just have to find out the area of this shape, and this will be equal to the size of this shaded area C, because A equals to C. So we found out the size of this shape. This shape consists of two smaller shapes. Consists of this sector MOA plus this triangle MOB. So total of this shape must be equal to the sum of the areas of those two shapes that it consists of. So the shaded area, but before that, because of the fact that those two semicircles are identical, they must have also the same area. So the area of this semicircle CB must be equal to the area of this semicircle AB. The area of semicircle AB equals to the area of semicircle CB. The area of this semicircle AB equals to A plus B, and it is equals to the area of this semicircle CB. The area of this semicircle CB equals to B plus C. So in total, we found out that A plus B equals to B plus C. If subtracting B from this equation, we found out that A equals to C. So as I mentioned before, because of the fact that those two areas are equal to each other, that is to say A equals to C, we just have to find out the area of this shape that is A, and this will be equal to the area of this shaded region, because A equals to C. So if we found out the area of this shape A, and A equals to C. This shape CBA consists of two smaller shapes. It consists of this sector MOA plus this line MOB. So the area of the shaded region in total must be equal to the area of the sector AMO plus the area of this triangle MOB. The area of sector AOM plus the area of triangle MOB. What is the area of this sector MOA? It is equals to pi r squared, that is the area of the circle that contains the sector, times the angle between the legs of the sector, that is 30 degrees, over 360 degrees. It again, so that the area of sector M equals to pi r squared times the angle between the legs of the sector, that is 30 degrees, or 360 degrees, plus the area of this triangle MOB. The area of this triangle MOB, we choose the base SOB, times the height to the base, that is MP over 2. And MP equals to H. So it is OB times H over 2. The area of triangle MOB equals to OB times the height H over 2. R is 5 over 2, therefore R squared is 5 over 2 squared, so pi R squared is 5 times 5 over 2 squared, divided 30 degrees over 360 degrees is 1 over 12. So total pi R squared times 30 degrees over 360 degrees equals to pi times 5 quarters squared over 12. Plus we have OB. OB is the radius of this semicircle, that is 5 halves. So OB equals to 5 halves times H. So we found out that H equals to 5 quarters. So H by 5 quarters divided by 2. So we have 5 over 2 squared is 5 squared, that is 25, over 2 squared, that is 4. So in total, pi 5 squared over pi times 5 over 2 squared is equal to 25 pi over 4, and we have to divide it by 1 over 12. So multiply it by 1 over 12. Here we have 5 times 5 is 25. In the denominator we have 2 times 4, that is 8, and 8 times 2 is 16. So in total, the shaded region equals to 25 over 4 times 12 is 48. So in total it is equal to 25 pi over 48, plus 25 over 16 square units in its size. Or in terms of numbers, is equals to 3.2 square units in its size. So if you found out that the area that we are looking for, this question that the size of this shaded region is equal to 3.2 square units in its size. Okay, thank you very much.